Hello, welcome back to Module 4, where we're going to have a look at the VISR SDK. Lewis is going to show us a demo similar to the previous one in Alps,
Yep.
but using VISR.
Awesome. Well, I'll move straight on. So yeah, we're going to talk about our implementation of VR and how you put that together in Unity, and how we're kind of planning to expand that, and how sort of using some of the more powerful features in there you can build something really quite special. So yeah, VISR VR Toolkit is going to be on our website, visor-vr.com/developer. You'll be able to download the full source, edit it, hack it, change it, do whatever you need to do. The basic idea is we want to build a really powerful toolkit that's going to kind of future-proof the developments you make now against future changes in the VR industry. So, we're moving quite quickly as an industry. We're going to be bringing new things into the SDK in the next 6 months. We're going to have like hand tracking and position tracking and support for peripherals and all that. So kind of it's a good thing to build into your projects, because you've got to kind of make sure that something that you build now isn't going to be completely out of date in 2 or 3 months, and you'll have to replace it all.
Yep, very cool.
So let's have a look at some of the features that we've got. Full distortion correction. So we've got that based on pre-configured viewer profiles. So similar to Alps, you can just select the viewer that you're using. It comes pre-configured to be compatible with the VISR headset, so you don't have to do any fiddling.
Yep.
Especially people at the Microsoft VR Hack will have a device that's pre-configured. We've got quality head tracking, so we spent probably a good few weeks on just the head tracking solution, and we're working really well with all the sensor APIs and everything else to make sure you've got a really stable track, one that doesn't drift or kind of do funny things, because like we said before, it's really important that you've got that kind of crystal clear idea of the orientation, because we don't want to make users sick.
Yeah.
We've worked to build a VR interaction framework into Unity itself, so similar to Unity's built-in methods like start and update, we've got things like on-viewer gaze and on-viewer gaze action, so you can do things like build content that reacts to being looked at or has some kind of interaction functionality.
I see. So you built a programming model on top of what's already there in Unity.
Yes, so that's kind of to allow interaction with the environment itself, and I'll show some of that in the demo. And then moving on, we're going to kind of fire up Unity. I'll show how to integrate it and load the packages. So let's jump over from current position into Unity. So I've got an empty Unity project here, and I'm going to use that to build out this scene. So the first thing I'm going to do is nip over to my Windows Explorer and go to the place where I'm keeping the packages.
Are you going to use our familiar scene?
Yes, so I'm going to build these all on that same sort of blue scene with the bottles in. And you get to see now kind of a secret reveal what the orange bottles were for, because we'll show that in this demo. So I'm going to bring in this VISR test scene Unity package. If it'll let me. There we go. So that's just that blue room that we've seen so many fun times before.
Yeah, interesting to see the drag and drop technique there.
Yes. Drag and drop, I think somebody called it once, in kind of that some winged creature is going to jump out of it. So yeah, just as before, we've got this kind of blue room with bottles and says VISR in the middle. So the next thing I'm going to do is going to come along and bring the SDK package in. So, unlike some of the other SDK packages, you see this is very light. It's based on some DLLs, and it's got some very light code descriptors. So you're not dragging hundreds and hundreds and hundreds of files.
Okay, but in the same way that we imported the Alps package,
yes.
It's a Unity package,
Yeah.
and you go through the same procedure to bring it in. Right?
Indeed. Double click import, and then the work's done for you. So if we look over here in the VISR folder, and in the prefabs folder, we've got some prefabs we can use to build the scene out of. Now, the way that we actually assemble scenes is slightly different. So the first thing I'm going to do is I'm going to get rid of my camera and my... don't think I need a directional light. I'll just have a check. Yeah, I've already got a directional light, so I'm going to get rid of that. And so I'm left with kind of the empty scene. And what I'm going to do here is, rather than sort of set up anything at all, I'm going to drag 2 things in that are quite important. So, earlier when we talked about kind of the components of a VR system, that's how we think about how this should be done. Okay. And this is helpful because it helps you configure it all. So we're actually going to drag in, just on its own, a tracking system. So this is a tracking system. It's default configured to work with a phone's kind of tracking position sensors. But if in the future you have some more exciting stuff on your phone, like the Google Tango sensor that gives you orientation and position in the room, or you've got some way of figuring out where the phone is, it's very easy to kind of plug those in. So if we have a look in this hierarchy, because it's set to being a phone tracking system, we've only got one thing we're tracking at the moment, which is the head. And basically what happens is, at this point, if you were to load this onto a phone, while it wouldn't render VR, you'd have that tracking point that was attached to the head point that would be moving around. So we've brought in this tracking system, and we have a named node called head. And what's great about this is we can attach to the head anything we might want to have attached to the head in the game. So let's say that your user's got a gun or a weapon or something that they're holding. You connect them all to that head thing, and they'll all follow the head around like you'd expect. So the next other important thing that we need in a VR program is the camera. So we're going to drag the camera into the head, as you would expect.
Okay.
And if we jump over into the game view now, you'll see we've got that nice barrel distortion like we had before. Let's just put that into a reasonable resolution. And when you run it in Unity, you can move around with the mouse and interact. So you can see that we've got kind of, as before, we've got those kind of key core components of head tracking, distortion correction, and stereo rendering.
Yep.
Let's just
and what settings do you have on those?
Yep. So these all
on the camera.
These all just drop in at the default settings. I made a mistake when I dropped it in, but you just drop it straight in. It just works straight away. No configuring, no moving it around, no messing around.
Yeah, but you can tweak the parameters in the same way that we saw with the Alps stuff.
Yeah. So just as in Alps, if you look, we've kind of got available for fiddling all of this. So if you are a hacker developer and you've got a custom set of lenses or you've got a custom tracking system, our real goal with this is to support kind of above and beyond just being a kind of a VR game tracking SDK. We want it to be about fiddling and hacking and kind of helping people innovate and create cool toys and things with VR.
Yeah, so you thought about the componentization of it.
Yeah,
in
so
some respects.
It's kind of highly modular in that sense, so that you can.
Yeah.
So we begin this building up. We've got this quite nice demo now where we're pretty much where we were before. What I want to do beyond this is start to think about interaction. So, if the people at the hackathon or people kind of watching this video going forward, you're going to be wanting to think about, the game design, what you're going to want the environment to do. And we've got tools to help with that as well. So we're going to bring in some other stuff that's quite cool. So one of the things that's really important in VR, if you're doing a position cursor, is it has to exist in the real world. Because if you imagine if you just saw kind of floating in front of you a dot, you wouldn't be able to perceive it very well. It wouldn't make much sense to you. So having an aim point in the traditional sense can actually be very confusing.
Okay.
So we have this aim point prefab in our nice prefab collection. And what we're going to do is drag it in and, as before, attach it to the head.
Yep.
Because we're thinking this is a component situation. We're sticking things to this person's head so that they can do more interesting stuff. And you'll see now, if we run the game, where the user's looking, there's now this white dot. And I don't know if you can see on the video very well, but the white dot kind of changes size depending on where you're looking, because that's actually appears as a disk in front,
that's
just
quite a
in front
nice
of the wall.
visual cue.
Yeah,
making sense.
So now all of a sudden we've got some kind of idea of where the user's looking, and what this scene is for, and why we've had this blue scene with the bottles in. The example game that we're going to use is one that makes the users align their viewpoint to the bottles, and then they can touch the screen, and the bottles kind of get shot off and fall over, and do sort of interesting physics stuff.
Yeah, cool. I want to see that.
Yeah. So if we nip back into the scene here and just fly down, you can see that these bottles just set up in Unity. They've got a collider on them and a rigid body, so they behave with physics. So the other thing that we're going to need from this is some kind of cue. Okay, when does the user press the button, and what is the user looking at? Now it's perfectly possible in Unity to program that ourselves, but it's a bit of a pain. It takes a while. So what we're going to use is the Visual Intent API, which is built into the VISR SDK. So we've got our camera, we've got our aim point. If you notice on these bottles, I've already dropped in. I'm just going to fix it, actually. I haven't already dropped in. A look receiver, it's called. So I'm going to drop a look receiver script onto the object. And now that's telling the SDK that I'm interested in when this object is looked at. And what that means is we can write a script now that receives those information, just like Unity would receive an on-collision event through the usual Unity collision system. So I'm going to open up this script I've got called Exploding Bottle. Here's one I prepared earlier. It's in the package. If you want to edit it, see how it's laid out. It's got all the usual hooks in. So just firing that up in Visual Studio. Very simple. So we've got this onLook state action event, which returns the raycast hit of the raycasting that's been done to decide what you've done. What's nice about that is we can actually take from the raycast hit all of that information of what the point normal is and its surface information and what object it is and what we've hit. So from then we're just back in Unity world and we can start to do Unity stuff to it.
Yeah, it's quite natural to write against those.
Yeah, so if you're sort of familiar with the API, it's just a nice little addition rather than being something else to learn. So I've got this code here that's just saying, get my current object's rigid body, because obviously I've attached this to the bottle, and add a force, which is the same as the ray hit's normal. And then it's an impulse, which means I'm going to hit it. So I'm saying, when I'm looking at it, when I've used an action, which is what unlock state action is, and that would be, pressing a button on the VR viewer or tapping the screen, I want to make the bottle shoot away in the opposite direction to where my touch is. So if you imagine it, kind of do that away from there.
Makes perfect sense.
Yep. So we've loaded that up. That's all ready. And now this is a live demo, so who knows what's going to happen. But fingers crossed, we should be able to knock some of these bottles off. So VISR SDK, when you're running it in demo mode in the editor, it takes the gyro information from the mouse and it takes your touch information from clicking.
Yeah.
And then obviously when you're running on the device itself, it works in a different manner. So let's have a look. Oh no!
Is it not picking up your click?
What have I done? No, I know what's up. That's perfectly fine. I have got to actually attach it to all the bottles because I was lazy and only attached it to one. So I'm just going to knit through and select all the bottles. Yeah. So one of them works. We should actually
it could take you a while to find that one.
So I'm just going to add look receiver to all of those objects. And now,
drum roll.
We're going to, what's the likelihood you reckon? Now we're going to, yeah, there we go. So now when we click down, that simulates the look action, and you can see the bottles kind of tumble off and roll around the environment.
Nice physics effect on there.
Chase them around the floor. And that's it's actually quite a nice, and we'll go onto it in the later modules, but it's a really nice example of that's what we would consider to be good VR game design. You're not flying around and the user's not feeling really sick. It's a nice, simple scenario with something that's mimicking real life. Bottles falling off a shelf. You'd expect that to act in a certain way, and it does. So right, we've built our game. We've got a great game idea. Let's look at how we deploy it. So we're going to open the Unity build menu. We're going to target Windows Store just like before, and we're just going to look at the player settings again. Just like
this looks familiar.
This is exactly what we did yesterday. Yesterday earlier. I'm going to target landscape left because that's how the orientation sensor has been done. Now the nice thing about the VISR SDK is it supports everything from Windows 8.1 upwards.
Yeah.
So if you're building a Windows Universal app, actually select Universal 8.1 rather than 10, and it will work on all the previous devices and all the 10 ones going forward. So you can support kind of the whole ecosystem. So we're going to go build. And then this being Unity, it's going to ask us for somewhere to put it.
I think, do you need to save your scene? I don't know if you...
It will probably ask me, if not. So let's add VISR demo, Windows Phone. Save it out. It'll do some kind of, there's a little hamster on a wheel going around in this. And like, it's building away. Hopefully it won't do a lighting build because, this video could be 3 hours long if it does. But yeah, I think you just let that put all the content into the packages. And the nice thing about this is it's designed to just click in and work. So for us, the reason behind all the blocks and the way we've built it is we want it to be more like experimental Lego, where you're sort of throwing a VR scenario together.
And you can reuse those parts.
Yeah, and edit them and hack them and modify them and bring in other things that are going to contribute to that environment. So it's kind of, if you are the hacker, the developer, you want to bring augmented reality in and use it in that kind of sense, then you can. There's nothing really stopping you.
And can people build on top of your SDK?
Yeah, so we'll be having we'll monitor the pull requests on GitHub, and if people want to build functionality into it, we'll receive them and kind of put them in. So our kind of vision for it, and it's going to be launched at the hackathon, the Microsoft VR hackathon, but basically our idea is it becomes this repository of hackers who are interested in modifying VR and creating their own sort of environments. Very nice. And then everybody benefits out of that, and that's hopefully we're going to have yourselves and Microsoft will contribute to it, we're going to contribute to it, the community is going to contribute to it, and together we will build the future. So I've got that ready to build. I've set my build settings, and I've got a Windows 10 phone here. Right, so we've got that running now on the phone. We've connected to that cool Continuum dock from before, so we can stream it out to the television, and let's see what we've created. So do you want to try it on and be the first guinea pig?
Sure.
I believe the interesting stuff is over there.
Okay, so how do I knock these bottles down?
So it depends which VISR headset you've got. So some of them have got mechanical buttons on, but most of the simple ones have got a hole in the bottom. So you just poke your finger through the hole in the bottom, and you tap, and you'll see that the bottles start falling off. It's just a really sort of nice introduction to doing VR interaction and the kind of games you might want to play.
Let's just knock these ones down.
Yeah. See if you can get them all.
Well, that was pretty bad.
The device not doing it while it's connected to a desk, I think that sort of ruined the immersion. But yeah, so you can sort of see there we've put together something that's actually in a very short amount of time, fairly functional. Add a score counter, add a little game loop, you're done. And that's kind of the really nice thing about having a modular SDK. You can just throw that together very quickly.
Yeah, very nice.
And that was what we intended to do. So, jumping back into the slides, that kind of concludes the end of our talk bit. Back to the using SDK, because actually if you'd have tried to develop all that yourself, you'd have spent all the time, building the rotation sensor and building the screen correction thing, and actually, the real goal here is to build something that's a new experience for someone, and that's what VR is kind of all about. So stick with an SDK, build something cool, and in the next lecture we're going to talk about actually what you're going to be building with it, the game design rules that go with all of that. So yeah, come join us in the next lecture, and we'll see you then.
See you in the next module.